Okay guys, so this is going to start our derivatives review. So this will probably be broken down into 3 or 4 sets with all the derivative stuff we learned over the semester. So let's get started on the notes. Okay, we defined average rate of change just like we do normal slope. It is the slope of the secant line. Your formula is f of b minus f of a over b minus a. So first example, if I want to find the average rate of change for f of x is equal to x squared plus 6x plus 9, I'm going to do f of 0 and f of 3. Remember that this is your a and this is your b. Okay? So I'm going to plug in a 0. You should get 9. 3 squared is 9. 9 plus 18. Just for the second time, I'm going to use my calculator. Try and do this without a calculator. Okay, so I get 9 and 36. So your slope is going to be f of 3 minus f of 0 all over 3 minus 0. Okay, so we get 36 minus 9 all over 3. And 36 minus 9 is 27. 27 divided by 3 is 9. Okay, next one. Find the average rate of change for this function right here. So we'll do f of negative 1 and f of 2. Okay, so 3x squared plus 7x plus 5, f of negative 1 and f of 2. So f of negative 1 should come out to be 1, and f of 2 should be 31. So we're going to do f of 2 minus f of negative 1 all over 2 minus a negative 1. Okay, so we should get 31 minus 1 all over 3. So it should come out to be 10. Now, if this is going to end up on this AP exam, it's going to look like this type of question. Okay, so the temperature of the water in the bathtub is modeled by pretty much the table up there. So for part A, it says use the data in the table to estimate the value of the derivative w prime of 12. Show the computations that lead to your answer. So we're going to locate where 12 is. Well, 12 is in between these two numbers. So I'm going to use the slope of the secant line, or the average rate of change, to estimate the value of the derivative at that point. Okay, so I get 67.9 minus 61.8 divided by 15 minus 9, and you should get 1.017. And it says make sure you use the correct units. Your units are going to be Fahrenheit over minutes. Degrees Fahrenheit per minute. Okay, so those are pretty easy questions. You'll have a few of those to practice on your homework. Revisiting differentiability. Okay, so in order for a function to be differentiable, it must be continuous. Things that have cusps or vertical tangents are not differentiable, but it has to be continuous to be differentiable. So this would be the definition of a cusp. This is a vertical tangent right here, just like in the figure. So make sure you know how to do that. Okay, so definition of a derivative. So we have 2 major definitions of a derivative. The general definition, the limit as h approaches 0, f of x plus h minus f of x all over h. And the definition of a derivative at a point follows this definition right here. Do I foresee this being on the 2020 AP exam? Probably not, just because the amount of questions we're going to have and the time to complete them. So I would say it's probably not going to be there, but we're going to work on this. Okay, so using the limit definition of a derivative, I want to find the derivative of this function right here. So we'll take the limit as h goes to 0 of f of x plus h minus f of x all over h. So we're going to do 3 times x plus h quantity squared plus 7 times x plus h plus 5 minus the original function, which is 3x squared, plus 7x plus 5, all over h. Now, we're going to simplify this out. So when we go to FOIL this out, it's 3x squared plus 6xh plus 3h squared plus 7x plus 7h. Remember on this, square the first, take the 2 in the middle and double it, square the last, and then we're going to distribute the 3 up. Okay, plus 5 minus 3x squared minus 7x minus 5. And this is all over h. Now a whole bunch of stuff should cancel. So we go to cancel this stuff. The 5's will cancel, the 3x squareds will cancel, 7x's will cancel. Okay, now we're going to factor out h on top. So we get 6x plus 3h plus 7 all over h. And we're going to take our limit as h goes to 0, so we should get 6x plus 7. And we should know that's the correct answer because we know how to take a derivative. Okay, the next two types of questions are asking you to take the derivative. Okay, it's given in the limit definition form. Okay, so this is saying evaluate the derivative of f of x. It's f of x minus f of c all over x minus c is the form we're looking for. So when we do these types of questions, we identify what our f of x is. So it's x to the 20th minus 3x. Now it's saying we're evaluating the derivative. So your derivative is that. And we're evaluating it at the point e. So it's 20e to the 19th minus 3. And that's how we do that question. Same thing on the next one, but it's not at a point. We're just asking, what does this mean? Okay, so you identify your f of x. Your f of x is sine of x because it follows the form just like we did up here at the top. And your derivative of this is just cosine. And that's your answer. Okay, listed on the next 2 pages are all your derivative rules that you need to be familiar with. Power rule, product rule, quotient rule, chain rule. All your trig derivatives, all your inverse trig derivatives, and all your exponential derivatives, okay? So as we go through this lesson, we're gonna take derivatives and we're gonna practice doing that. So this should be relatively easy for you guys to do. Shouldn't be any sort of issues with this, this set because y'all can take derivatives pretty well. Okay, so we're gonna use power rule. The derivative of this function should be 3x squared plus 14x minus 6. The next one, we're going to rewrite this as x to the 1/7 power minus x to the -4th plus x to the -7/3. Remember, if it's on the bottom, you have to write a negative exponent. So when I go to take my derivative, make sure you write f prime of x. Okay, it's 1/7 x to the -6/7 plus 4x to the -5 minus 7/3 x to the -10/3. Okay. The next question, we can do a product rule or we can FOIL it out. It doesn't matter. It's about the same amount of work. So f prime of x, I'm going to write the first term. Derivative of the second term is 5x to the 4th. Plus, write the second term, derivative of the first term. Okay, if you want to simplify this one, you can. Really don't have too much time to do that right now in my video. So you can simplify that in your own time. This one, f prime of x. So we have division going on, so we're going to have to use a quotient rule. So write the bottom, derivative of the top, minus write the top, derivative of the bottom, all over the bottom squared. Okay, so this one's easy enough to simplify quotient rule, so let's go ahead and do that. 6 times 6 is 36x plus 30, and this is 36x minus 12 and then we're going to distribute our negative sign. So we should get 42 all over 6x plus 5, quantity squared. Okay, next one, f prime of x. So we're going to have chain rule involved because we got something other than x being raised to a power. So it should be 10x to the fourth minus 2, all raised to the fourth power times 4x cubed. So 40x cubed, x to the fourth minus 2, all to the fourth power. Okay, this one turns out to be really easy because sine squared plus cosine squared is 1 from our trig identity. So the derivative of 1 should be 0. Okay, next question. We're going to have a product rule. So we're going to write the first term. Derivative of sine is cosine. Plus, we write the second term. Derivative of the first term is just 1. And we're going to leave our answer like that. Next question. F prime of x, we're going to bring the 7 in front. Reduce it by 1. And take the derivative of the inside. Now, hopefully you're able to kind of keep up with me on this. I know I'm going a little bit fast, but you can always slow down and rewatch the video if you didn't get it the first time. Okay, on to the next page. Now, anytime we have a trig squared or cubed or raised to a power, we need to rewrite it first. So I'm going to rewrite it like that. Okay, so we're going to bring the exponent in front, reduce it by 1, and then we have to chain rule the inside. So the derivative of tangent secant squared, we keep the angle, and then we have to chain rule the angle again, like that. Next question, we're going to have a product rule. So we're going to write the first term, derivative of the second term, plus write the second term, derivative of the first term. Okay, and that's it. Remember, pi squared is just a number, so the derivative number is 0. Derivative of cosine should be a negative sign. We're going to keep the angle. And then we're going to take the derivative of the angle. So it looks like that. Okay. This is not a product rule. This sign right here is the angle. So we're going to work outside in. So the derivative of sine is cosine. We're going to keep the angle. And then we're going to chain rule the angle. So the derivative of sine is cosine again. So your answer looks like that. Next one, we got a quotient rule. So we're going to write the bottom. Derivative of the top. Minus, write the top. Messed up, sorry. Write the top. Derivative of the bottom should just be 2. All over the bottom squared. Now, hopefully you'll recognize some of these problems. I'm using old test questions for this review. So you have new questions to work on in your homework. Okay, this one. Derivative of cotangents, a negative cosecant squared. We're going to keep the angle. Okay, the derivative of cosecant is a negative cosecant cotangent and then we have to chain rule the angles. So you should get 25 x to the fourth minus 4x to the negative 2. All tagged onto that. Okay, and on to the last page. So, zoom in just a little bit. So we got a chain rule. So we're going to bring the exponent in front, reduce it by 1, and then we got a quotient rule. So we're going to write the bottom, derivative the top, minus write the top, derivative the bottom is 3, all over the bottom squared. Okay, we're just going to leave it like that. Derivatives e's are either u du, so we write it. And then we take the derivative of the exponent, which is 4x plus 9. Next one. Derivative of a number raised to an x power is a to the u du natural log of a. Derivative of natural log is du over u, so it's going to be 12x minus 4. Okay, so 12x minus 4 over the original. And the derivative of arctangent is du over 1 plus u squared. Your u is going to be 4x, your du is 4. So when I square this out, I square both terms, I get 16x squared. Okay, last two questions and we'll be done with this homework, with this example set. Okay, the derivative of arc sine, okay, it's in your notes. The derivative of log with a different base is also in your notes. So we got a product rule right here. So we're gonna write the first term. Derivative of the second term. It's du over u natural log of the base, natural log of 3. Plus, we write the second term. Okay, and then the derivative of the first term, derivative of arc sine, is du over the square root of 1 minus u squared. Like that. And then our last question is going to be a quotient rule. I'm going to write the bottom, derivative of the top, minus write the top, derivative of the bottom, should be 9e to the 9x plus 7, all over the bottom squared. Now make sure you don't forget your bottom squared. One of the common mistakes that y'all messed up on. Okay, so this was a quick review over derivatives, basic differentiation rules. The next video will go into things like equation of a tangent line, implicit differentiation, and that sort of thing. So I'm trying to break it up so you're not too overwhelmed all at once. So hopefully this helps, and I will be posting the homework that goes with this set. Thanks and have a good day.